Now, just before we move on to today's lesson for exercise 14F, which is about finding the exact values of trigonometric ratios, we're going to just review a couple of questions from exercise 14B and 14C. Okay, so this was about values of sine, cos, or cosine, and tangent values. Okay, I'm going to stash this away over here so I can copy and paste it because, you know, I can. Example, part number 1. So which questions did you kind of have issues with? Just all of it? 1? Okay. Now it says here, for each of the following angles, determine the values of sine and cos. Now, just to recap, what does, I don't want a big circle. I want a small circle. What does cos measure? The x value, okay. What does sine measure? Y. And what does tan measure? The gradient. Fantastic. Okay, so the important part here is to find the location first. We need to find the location of where these angles exist. Oh. So, for part A, it's asking when t equals 0. T is an angle. Don't know why they use t. Usually you would see this as theta. Okay, so if you want to use theta, fine. Right, but just know that it doesn't always have to be theta. It can be x, it could be y, it could be t. So the variable can change, yeah? But for the sake of getting used to it, I'll put theta here so it's easier to look at. So where is the location of where theta equals to 0? Is this 0 radians or 0 degrees? Is there a degree symbol on there? So by default, if there is no degree symbol on there, then it's automatically radians. Okay, so all of these here are in radians. Okay. I'll do this quickly. 0 radians is located here. Whoops, I just put degrees. So 0 radians is located there, right? There's a couple pieces of information about this point here. Remember, we're still on the x and the y axis. So the coordinate there is 1, 0. What else do we know about this here? There's also a line, right? The line that runs horizontally gives us a gradient of 0, right? So the gradient of a flat line is 0 as well. Isn't that your cos, your sine, and your tan? So what's it asking here? It's asking what's the value of sine theta and cos theta? Well, we need to substitute this for theta equals 0, right? So if we say, okay, I want to find out what sine is, I'll actually do it in color. Sine theta here, what does sine measure? Your y value at, an angle of 0. The y value here is 0. What does cos measure? So the value of x when the angle is at 0 is 1. And that's that 1 here. Tan of theta. Tan of 0. What is the angle at, what is the gradient at an angle of 0? 0, because it's a flat line. So the important thing here is to be able to find where you are locating your point. So for this example here, for this question here, you can see that we have 3 pi on 2. 3 pi on 2. So here's 0 radians. If we want to go 3 pi on 2, we rotate anti-clockwise because it's a positive direction. So at this point here, the angle is 3 pi on 2. That's where 3 pi on 2 is. What's the coordinate at 3 pi on 2? 0, -1. And what's the gradient of that vertical line? 0 or undefined?
0.
Undefined. Why? Because it's a vertical line. Can you climb a vertical wall? No, undefined. Flat. If it's flat, you can walk on flat ground, right? Gradient of 0. Cool. So we've got, I'm just going to write undef. So for undefined. So what is our sine value at 3 pi on 2? -1, because sine measures the y value, as you can see. So really, we're just focusing on this part here now. What is cos of 3 pi on 2? 0, because the x value at 3 pi on 2 is 0, right? Cos measures the x value. And tan of 3 pi on 2?
5 to whatever equals to that.
To this point here. How did I know? Okay, so here's 0 radians. If I go all the way around, what's a full revolution in radians? Sorry? 2 pi, correct. What's halfway? Pi. If I just go halfway. This is 1.5 pi, isn't it? So that means between 1 and 2. So 1.5 is here. True? Like I said, by the end of this chapter, hopefully you'll become really good at fractions and understanding, you can break things up. All right. So does that make sense? Does this shift your perspective now for the unit circle? Sine, cos, and tan measures. Okay. Cos, sine, and tan measures the x, y, and gradient. Cos measures the x, sine measures the y, tan measures the gradient of the line. Is that clear? Does that clear up the air? The air? Oh, whoops. Anywho. Now, what happens if we have this here? Please put headphones and do not play this aloud in front of your family while at home. Thank you. Sine of 1.9. We need to actually find out where this location is. Right? Where is 1.9? This is hard to actually measure because it's not in pi, right? Now, in this particular case here, it's actually easier if we convert it to degrees, right? Because right now it's in radians. There's no degrees on there. So when we go to, actually, what was the question asking? It says, yeah, use your calculator. Never mind. But you can convert it to degrees if you want to know where 1.9 radians is. So let's say this is 1.9 radians. How do we convert this to a degrees? Times by? Correct. Okay, so that's around 109 degrees. Okay. But when we go to type it in our calculator, it gives us a value of 0.946, which is 0.95, yeah? Take note. In the top right-hand corner here, if you have RAD, that means your calculator is set in radians. If I click this, it changes to degree. Okay? Be very careful with this, especially if you are doing methods and general maths together. Right? Because you can get this wrong real quick if you don't switch the mode. Usually you should keep it in radians for methods. Okay. If I leave it in degrees and I put 1.9 here, the calculator picks this up as 1.9 degrees. Okay. That's why it gives you a different value. So be very careful. You should have it on radians. Okay. However, you can still calculate 108. I'm going to take this here. Yeah. That's in degrees, isn't it? So I need to put the degrees symbol. If you have a look down at the keyboard here on the left, there it is. Yep. Right. Where the question mark and the exclamation mark is, you should see a degrees symbol. If I chuck a degrees symbol there, now it's saying, okay, sine of this many degrees. You press enter. Notice radians, degrees. Okay. But what does this mean? Because right now, this just looks like a number to us, right? What does this look like on the unit circle? Question mark. Well, we know the location of the angle, do we not? We do. So let's find the location of this angle on the unit circle. So on the unit circle here, what angle are we looking at? Right, 109 radians or degrees? 109 degrees. That's easier to find than 1.9 radians, yeah? So where's 108 degrees here? We know that this from here to here is 90 degrees, right? So 108 degrees goes from 0 past 90. I'd say it's around here-ish. Okay? There's our point. There's our angle. So this is around, well, that's 1.9 radians, which is the same as 100 and, well, roughly 109 degrees. So our calculator gives us, they want us to 2 decimal places, right? No, but sure, we'll just do it to 2 decimal places. 0.95. What does this 0.95 mean? What does sine measure? The y value. So this point here, this pink point has a coordinate, yes? Do we know the x value for it? No, we do not. So I'm going to leave that blank. Do we know the y value for it? All right, that's 0.95. Have a look at how close it is to 1. The y value of 1. Does this make sense? So it's just another point on the unit circle. Same with these here. Just find the location of it, explore it, and see where it fits on the unit circle. I know it just says put it in your calculator, but if you really want to understand it, draw it out and see where your location is. Check if this is actually correct. Does that make sense? So that's an exercise for you, like a bit of an extra exercise. Don't just focus on doing the questions. Focus on doing the questions to understand it. Now, there's one more here. And this is like still part of 14B. Did I just say the part? Not. Anywho, we have the unit circle. I'm tripping all over my words today. Now, let's say we pick one of these questions that look really ridiculous, like 211 pi, or 9 pi over 2, or negative 53 pi. My goodness, they look bonkers, right? But these are not difficult questions, because what are we trying to do here? What do we need to do first if we have an angle? We need to locate where it is on the unit circle. Once you find out the location of the unit circle, you will be able to find your sine, your cos, and we'll just throw in the extra of tan as well. Negative 9 pi on 2. Where is that located? Now, you can sit there and say, okay, I need to go clockwise or anti-clockwise? Clockwise, okay. Pi on 2, how many times? 9 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so there's my location of negative 9 pi on 2. Does that make sense? Cool. Yeah. So that's how you find the location of 9 pi on 2. 9 pi on 3. 9 pi on 3 is the same as 3 pi. So that's located here on the left-hand side. Big brain. Does that make sense? It's about segmenting it. But for this one here, we're just breaking it up into pi on 2 and whole pi's, right? So once you find the location, what's the coordinate here? 0, negative 1. And what's the gradient? Undefined. So therefore, what's your sine, cos, and tan? Sine measures the y, cos measures the x, and tan measures the, that is correct, which is undefined. Can you see it's just capturing pieces of the information that's presented to you? So what happens when you are given an angle? You must find the location on the unit circle. Okay. 211 pi. Is this a odd or even pi? Odd. So what did we say about odd and even pies? Where are they located? Correct. Odd is on the left, even is on the right. Right. So here is, without even trying to rotate, we're not going to sit there and rotate anti-clockwise 211 times. Right? We understand the pattern. We go straight to it. That's where 211 pi is. What's our x, y, and what's our coordinate and our gradient? Sorry? Look at the pattern. 0 is here. Pi is here. 2 pi is here. If we keep rotating anti-clockwise, we rotate another halfway. That's 3 pi. And then 4 pi, 5 pi, 6 pi, 7 pi. Right? So it just goes half, 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 half. And then from this, so this is the idea of going beyond, right? Now you make a prediction, or you start to notice the pattern. Oh, well, on the left-hand side, it's odd. Oh, I notice here on the right-hand side, it's even. So that's how we came to that. Okay. Coordinate is negative 1, 0. The gradient here is a flat line. Horizontal. So what's the gradient? 0. So sine of 211 pi is 0. Cos of 211 pi is negative 1. And tan, just to throw it in, of 211 pi is also 0. Negative 53 on pi, is that odd or even? Next question. Odd, so it's located on the left-hand side, not the right-hand side. Okay, good. So that's where negative 53 pi is. What do you notice? Coordinate is the same. Gradient is the same. I can't be bothered writing that out. I'm just going to duplicate it and change the angle on the inside. So on your paper, drag and copy and paste. Just joking. Get your scissors and cut it out. Does this make sense? So values on the unit circle, right? Now you understand the basics. You should be able to do 14C as well. It's the same thing. Yeah? We good? Okay. We're going to move on to 14F now. Now, today we're actually going to spend a bit of time in detention writing out repetitively the same information. I'm going to make you write it out 5 times so that you understand. Okay? You will want to start a new page for this. So on your page, so 14F, exact values in the unit circle. This is our title. There are a few exact values, right? In terms of when we say exact values, we need exact angles, or what I like to call them is base angles. We did have a look at base angles, I believe, in our last lesson. We had different splits, right? So we know that we can divide it into pi on 2. We can divide the unit circle into pi. You can see here, so halfway. We can divide it into pi on 2, which is like every quarter, 1, 2, 3, 4. Right? We can divide it into pi on 4. So starting from 0 here, we can go pi on 4, 2 pi on 4, 3 pi on 4, 4 pi on 4. That's equal to 1 pi. 5 pi on 4, 6 pi on 4, 7 pi on 4, 8 pi on 4, which is the same as 2 pi, right? So we can divide it and split it up like this. Pi on 3, 2 pi on 3, 3 pi on 3, 4 pi on 3, 5 pi on 3, and then back to 6 pi on 3. So pi on 3 is another important angle that we kind of need to know. And pi on 6 as well. Now, with each of these here, right, we know that these are points, coordinates on the unit circle. So we need to actually know the x value, we need to know the y value, and we need to know the gradient at this point as well. Does that make sense? But if you try to put this into your calculator, you'll notice that it comes out to be something. It's going to give you surds. So it's going to give you square root of something and over another number. Okay. We are going to write this down so you understand. And you're going to draw out the unit circle. Just do it as fast as you can and label it as quickly as possible as an exercise. Because I want you to understand first. And then we're going to find out a way how we can actually calculate these really quickly. Now, what I'm going to do here is I'm only going to capture the first quadrant. Because this is where our base is, right? So on your page, I'm going to do it like this. I'm going to split it into thirds, right? So 1/3 at the top and 2/3 at the bottom here. In the first third, I'm going to just focus on the first quarter of the unit circle. We're only going to focus on the first quarter of the unit circle. So our base angles are going to be pi on 6, pi on 2, Sorry, pi on 4. I'm just going in order here. Pi on 3 and pi on 2. And we also have 0 here as well. So notice how I'm going, the angle's increasing every time. Understood? Excellent. Each of these points here have a set of coordinates. All right, they each have a set of coordinates, and they each of these lines is a gradient. We already know the information for 2 of those points. In fact, maybe even 3. Can you please fill out the information for these 2 points first? I want your x value, your y value, and your gradient. Oh no. So you can see here, we've got the information filled out for 2 of our points here. Right? But now we need to fill out the ones in between. I'll start off with a pi on 6 here. The pi on 6 here, okay, it doesn't look exactly accurate because I don't think I drew it to scale. But it looks roughly around, what's the y value? We know that the y value distance here is 1. What do you reckon this distance is? 0.5 or 1/2, yeah? Correct. So what does that mean about our y value? It's 1/2, right? I'm not going to write it in decimals. I'm going to write it in fractions. The x value here is pretty close to 1, right? It's pretty closer to the x value of 1. In fact, it's 0.86. But we express it as an approximate or exact? Exact values. That's why it's called exact values. If you type √3 on 2, it's roughly about 0.86. √3 on 2 is the exact value there. Yeah. So if you type in √3 on 2 into the calculator, square root 3 over 2, whoops, is roughly equal to 0.866. Does that make sense? So instead of writing 0.87, we'll write √3 over 2. It's exact. The gradient here is equal to 1 over √3. Okay? 1 over √3 is less than a gradient of 1. Don't worry about the values too much right now. I'll write out the rest of the information here. If you have a look at the x value here and the y value here, that's a value of √2 on 2. And this is also a value of √2 on 2. You can see they're actually the same distance. So what shape did I just draw? A square, correct. Because it's perfectly, the line is perfectly diagonal. So what's the gradient if we have a perfectly diagonal line? 1. Wahed. Seriously? Yes. Now, what do you notice here between this angle and this angle here? Same, exactly the same, or is it kind of like it's a reflection of each other, right? You can say it's a reflection of each other on y equals x. So what does that mean about the x and the y value? Yeah, the same, but they're switched around their positions, right? So what's the x value this time for this position? 1/2, because you can see here, The x value is 1/2. What's the y value? √3 on 2. And our gradient, what do you reckon happens to our gradient? It flips, so it's now just √3. So that's the first quadrant there. Now we're actually going to, in the bottom half of this, oh, where did my line go? In the bottom half of this section now, what I'd like you to do is draw out a big unit circle. Doesn't have to be perfect, but just a big unit circle.
Can you give me those statements?
Because the exercise now is to go through the entire unit circle, and I want you to label out the x value, the y value, and the gradient. And I want you to split up this unit circle into all parts possible for exact values. So I'll start here. What I like to do is I like to split this in half first. And then we know that there's another 2 splits that occur. One at 30 degrees. Now notice how I'm not going to line this. I'm not going to split this exactly in half, yeah? Because you can see the x value is not 0.5, right? The x value should be somewhere up here. So that at this point, that's where the line should be, not this bottom one. That's where pi on 6 is. Does that make sense? This one here is pi on 4. This one here is 0. So where's pi on 3? Is it exactly halfway here? No, we want to move it so that this x value lines up to be 0.5. Yeah, so I might move it down a bit more. So that's where pi on 3 is. Realistically. Does that make sense? So I want you to go from 0 up to 2 pi. So I want you to continue with this pattern here until you get all the values. √3 on 2. 1. Finding some coordinates, sir. Yeah. For the entire unit circle. Oh, nice, good. Now I want you to fill it in. The others, that's what we're going to get to, right? If you write this part again. Correct. So the exercise here is that when you go around the unit circle, these 3 lines here will be reflected over on the left-hand side now. Same with this horizontal line, we'll go over here. Right? Let's draw that in first and we'll figure out what the angles are. I'm going to draw the diagonal line in first because that gives us a reference point. The first line is going to be around here. Oh no, glitch. That glitched out pretty hard. And another line that reflects here as well. Now, we want to label those angles between 0 and 2 pi. What's this one here going to be? 3? This one's pi on 3. So this is your 2 pi on 3. Because there's 2 of those pi on 3s. That's a second line, yeah? And then what's this one here? Pi, which is the same as 3 pi on 3. Does that make sense? Yeah? So the angle here is I'm going to write is 2 pi on 3. It makes sense. 1/3, 2/3, 3/3. Right? Put your filter on. Put your filter on. So you know how you put on different filters and you can see the world in like different colors. Here we're putting filters on to see this unit circle in different segments. Yes. This is pi on 4 here. So what would this one be? Ah, gotcha. 1 pi on 4, 2 pi on 4, 3 pi on 4, 4 pi on 4. Does that make sense? No? So this one reflects this one, right? This is 1 pi on 4. That's this distance here. This distance here is how many of those pi on 4s? 2 of them. That's why 2 pi on 4, if you simplify the fraction, is pi to 2. Right? But then I'm going to count another. So how many pi on 4s is this worth? 3 pi on 4. Okay, now we're understanding. Right? And then this one here would be 4 pi on 4, which is the same as, if you simplify it, pi. Oh. Okay, so what's this one here then? Sorry? 5 pi on 6. Use this as a reference point. Okay, so this is pi, right? That's the same as 6 pi on 6. How much did you go backwards by? You went back by pi on 6, yeah? So that's 5 pi on 6 now. I'm showing you a different perspective. Otherwise, you can go 1 pi on 6, 2 pi on 6. You can see here, that's the same angle that I'm traveling here. What's this one here? 3 pi on 6, 4 pi on 6, 5 pi on 6. Does that make sense? But I said this one here was 4 pi on 6, didn't I? Simplify that fraction. That's the same as 2 pi on 3. Yeah? Yeah. And then this one is going to be just pi. Right? Because otherwise, if I just say, okay, where's this located? You won't understand unless if you understand fractions in the unit circle. We're going slow to go fast. Does that make sense? Because I'm building the foundations here for you. What? I like that. Nizar quotes, sometimes in life you need to go backwards to go forwards. Yeah. Right now, if you're burnt out, you need to slow down to actually be able to pick up again. Does that make sense? Okay. Have a look here. What is our X value here? What is our X value? It's similar to this, yeah? Is it the same? What's our X value? It's -1/2 because on our X-axis here, we're on the negative side now. Here's 0, here's -1/2, here's -1. Okay, so the X value here is -1. So, -1/2. What's the Y value? It's the same. Okay. √3/2. And what's our gradient? Yeah, so this is positive √3. It's the same kind of like steepness, right? But in this case, it's going, notice I'm not going to draw out like this. Do not draw out like that. Always go from left to right. And you actually see the direction is going down. So that means our gradient is negative. All right? Cos, sine, tan. Okay. Continue on. What's the x value here for 3 pi and 4? Okay, our x, what do you notice about our x values now? You mean our x values, they're negative, but our y values stay positive. Yep. Gradient here is, what do you notice about our gradient here? It's -1, correct, because it's the same angle over here, but it's going in the opposite direction. It's going down this time. Yo. So write it out. I'm punishing you. Every single one. So I'm really punishing myself as well. So yes. That's what it means to lead. Don't be a boss, yeah? A boss would just tell you to do it, but they won't do it themselves. A leader tells you to do it, but you also do it yourself. Does that make sense? So be very careful. Say, for example, you meet a friend someday and they have a business, right? And then they say, listen to the phrase here. Come work for me. I'm the best boss, right? Who would you work for? This friend or friend B who says, come work with me. I'll show you the way. Okay. Just simply in the language. You have to be careful about this when you get into life. Anyways, just a bit of a tangent. Continue on. Or that. So I'm trying to line this one up here so it makes 0.5. Same with this one here, except I'm lining that up to make 0.5 on the x-axis. Question, what's the angle here? 5 pi on 6? 6 pi on 6? 7 pi on 6. Cool. Yeah. What about this one? What about the diagonal one here? This is 4 pi on 4 here. So notice how I'm using this as a reference now. I just change it to 4 pi on 4, right? So if I go another pi on 4, that's 5 pi on 4. Correct. You notice this one here is based on pi on 3, yeah? So 3 pi on 3 and then 4 pi on 3. If you still don't understand this, pause the video, rewind, and watch it again. What's this one here at the bottom? Pi on 2? Pi on 2 is here. 2 pi on 2? 3 pi on 2. Okay, again, write out your values. What do you notice about the x value and the y value now? So notice I'm going to use this one as a reference, right? Can you see how this one is similar to this one? Except what happens to the x value? All right, one's positive, one's negative. So this one here is negative. And what about the y value? It's also negative. Have a look at where we are in terms of the x-axis and the y-axis. We're actually in the negative section for x and y. The coordinate system, right? Remember, these are coordinates. Now, what do you notice about the gradient here? Is it going up or down? So it's positive, right? So the gradient, have a look at the slope of these two lines here. They're actually the exact same. So 1/√3. So use the first quadrant as the reference one. Again, you notice that I'm going to look at this one here. And I'm going to make reference to that. And m is equal to 1 as well. So for homework, I would like you to draw this out 5 times. 5 times. Fine, 3 times. Okay. The x value here is -0.5. The y value is also -√3 on 2. Because I'm looking at this one for reference, right? Because you can see here, these lines are similar. And the gradient is +√3 as well. And now once we get up to this line, sorry, this line here, it's not 0, 1, is it? What's the coordinate down here? 0, -1, and the gradient is undefined. You mean 1/0, rise over run, yeah? Rise over run is y/x. Once you understand this, then I'm going to teach you how to calculate these values more quickly. But just before we do, 7 pi on 6, 8 pi on 6, 9 pi on 6. Sorry. 9 pi on 6 is the same as? Oh, sorry. Sorry, which one? Yeah? Is it 10 pi on 6? Okay, simplify. Because we counted like smaller segments. 1, 2, 3, 4, 5, 6, 7. Sorry, I forgot pi on 2. My bad. Backtrack. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's if we count up as pi on 6. But if we count as pi on 3, 0, 1, 2, 3, 4, 5 pi on 3. And what's this one here? We understand now that this perfectly diagonal one is related to pi on 4, yeah? 0, 1, 2, 3, 4, 5, 6, 7 pi on 4. This one here is related to pi on 6 because you can see it's a very similar angle, yeah? Instead of counting to 6, we already know that this is 6 pi on 6, yeah? So we'll start here at 6 pi on 6 instead of counting the top half again. 7, 8, 9, 10, 11 pi on 6. Haram. X value. Notice here, the X value lines up with. So what do we notice here? There's a properties of what happens when there's one side is the same as the other? Reflection, but if it's exactly the same, what about a parabola? One side is exactly the same as the other. Symmetry. So there's properties of symmetry within the unit circle, right? Now, I could have just gone to this here and said, all right, everyone, look, there's symmetry properties in the circle of functions. See this here? That's equal to this here, blah, 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 right? I could just teach you straight from the textbook, but I want you to discover it instead. Discovering it takes time, yeah? But then you actually understand it. If I just tell you what it is, then you're actually rote learning. Does that make sense? I want you to understand how this works instead. So we got 1/2. What's the y value down here? This y value down here is the same as this one down here, isn't it? So it's a negative √3 on 2. So what's our gradient here? This gradient is similar to this gradient up here, isn't it? So m equals negative √3. This one here is positive √2 because the x value is in the positive section, right? And the y value is in the negative section, so negative √2 on 2. The gradient here, what's the gradient of this line here? -1, because it's the same gradient as this line here, yeah? And last but not least, the x value is here. It's the same as this one up here, so √3 on 2. So notice once you understand the first quadrant, all the other quadrants fall into place. And the y value is -1/2 because you can see this y value here is on the negative y-axis, but it's the same as the one over here. Okay. Gradient, -1/√3. And if we go back here at 2 pi, again, it's the same information. Now, looking at this unit circle here, I'm going to test you now. What is sine? Write it on your paper. What is sine of 4 pi on 3? Sine of 4 pi on 3. What am I looking for? -√3/2. How did I get this? What does sine measure? The y value. Where is 4 pi on 3 located? Right here. So we're looking at 4 pi on 3. We're looking at the y value. It's -√3/2. Yes. Does this make sense? Rob? -5 pi on 2. Absolutely. Now, notice here, we've only done angles between 0 and 2 pi, right? Negative pi on 2. You said -5 pi on 2, yeah? Negative pi on 2. -2 pi on 2. -3 pi on 2. -4 pi on 2. -5 pi on 2. -5 pi on 2 is located right here. So the information is exactly the same. Does this make sense? Yeah? So once you find the location, I could ask you, okay, where's 20? I'm going to challenge you now. 23 pi over 6. Where's this located? Isn't that really close to 24 pi on 6? But you have to get back to 23, you need to subtract by pi on 6, right? What's 24 pi on 6 the same as? 4 pi minus pi on 6, yeah? Where's 4 pi located? Keep that in mind. 4 pi minus pi on 6. 4 pi is located on the right. If you're subtracting pi on 6, which way are you going? Clockwise by how much? Pi on 6. This is where, what did we say? 23 pi on 6 is located. So it captures this information here. So I could ask you, okay, what's cos of 23 pi on 6? Root 3 over 2, correct, because it tells you the cos measures the x value. What's sine of 23 pi on 6? Negative a half, because sine measures the y value. What's tan of 23 pi on 6? Negative 1 over root 3. Done. This here is so important to understand, right? But so have this here for exam 2, right? Have it in your book, your knowledge book for exam 2. What if we were in exam 1 though? Oh no. And that's for our next lesson. That's for our next lesson. There is the hand method. There is also this method here. Pi on 4. So what's sine of pi on 4? Well, it's square root of 2 over 2. Sine pi on 4. Sine pi on 4. Square root 2 over 2. Okay, we're going to learn how to use this. We're going to learn how to use this table, but I'm also going to teach you the hand method. This is why I taught you this. And everyone, that's the hand. And here. X and Y axis, 3 fingers. Which one's your pi on 3 finger? Your index finger. What's pi on 4? This one. All right, everyone, pack up. Yes, I did.